Good morning, dear children. Welcome back to our online maths class. Okay, which topic is being discussed nowadays? Yes, nowadays we have been discussing about powers, isn't it? We have been discussing about powers or power form of an integer, isn't it? Okay, what is meant by power of an integer? Yeah, if an integer is multiplied by itself, it is known as the power of that integer. So here we have multiplied 2 how many times? 2 is multiplied how many times here? 1, 2, 3, 4, 5. 2 is multiplied 5 times. So how can this be represented in the power form or in the exponential form? Here 2 is multiplied 5 times. So which number has to be written first? Yes, the number which is being multiplied has to be written first, isn't it? And which is the number which is being multiplied is what here? Yeah, 2 is the integer which is being multiplied, isn't it? And 2 is known as what? Yeah, 2 is known as the base of this power form. 2 is known as the base of this power form. And 2 is multiplied how many times? 2 is multiplied? Yeah, 1, 2, 3, 4, 5 times. And that 5 has to be written above. Size of that 5 should be small. 5 should be smaller in size, isn't it? 2 is multiplied 5 times and 5 has to be written above, and size of that 5 should be smaller than that of 2, isn't it? And this 5 is known as what? Yes, this 5 is known as power or exponent or index. Power or exponent or index, isn't it? Okay. And what else has been discussed yesterday? Yeah, yesterday we have discussed that this base of a power form can be either negative 0 or positive, isn't it? And what else? Yes, even power of a negative integer is positive. That means if we multiply a negative integer even number of times, the answer sign would be positive. Sign of the answer would be positive, isn't it? That is, if we multiply negative 2 4 times, if we multiply minus 2 4 times, what would be the sign of the answer? Of course, 2 2s are 4, 4 2s are 8, 8 2s are what? 8 2s are 16. 16 would be the answer. But what about the sign of this answer? How many minus signs are there in the question? 1, 2, 3, 4, isn't it? So, as per the rule of multiplying integers, if odd number of minuses are there in the question, even number of, and 4 is an even number, we all know. Here we have 4 minus signs and we all know that 4 is an even number, isn't it? Okay. So, as per the rule for multiplying integers, if even number of minuses are there in the question, sign of the answer would be what? If even number of minuses are there, sign of the answer would be, yes, plus, positive, isn't it? So, here also what would be the sign of the answer? Positive. Plus 16 means what? 16, isn't it? Okay. And if odd number of minuses are there in the question, what would be the sign of the answer? What would be the sign of the answer? If odd number of minuses are there in the question, the sign of the answer would be, yes, negative. So, what would be the answer? Minus 2 into minus 2. Here what would be the answer? 2 2s are 4, 4 2s are, yes, 8. Okay, what about the sign? Here in this product, how many minus signs are there? 1. This is minus. Okay, 1, 2, 3. 3 minus signs are there. Is 3 even or odd? Yeah, 3 is an odd number. So, if odd number of minus are there in the question, what would be the sign of the answer? Sign of the answer would be negative. So, minus 8, isn't it? So, generally, what can be concluded? Generally? Yes, even power of a negative integer is positive and odd power of a negative integer is what? Negative, isn't it? All these have been discussed in our previous class. Okay, now let's start doing problems from this session, problems regarding these results. After that, we shall learn the next topic. Okay, now let's start doing problems from this session. After that, we shall discuss the next session of this lesson. Okay, is it clear? Okay, now please start writing. As I have been saying always, please mention date and day on the upper portion of your margin before start writing. Okay. Okay, now please start writing exercise 6.1. Exercise 6.1. Okay, I would like to tell you one thing. As I have been saying always, the questions in your textbook and the questions what we are doing now may not be the same, but surely we will cover all the concepts given in the textbook, all the important concepts. Once you are thorough with the concept, you would be able to do any problem related to this content on this session. Okay, yeah, please write down first question. First question is, represent the following in the exponential form or the power form. Represent the following, represent the following in the exponential form, in the, first we can write in the power form, in the power form or the, which is the other name of power form? Yes, or the exponential form, or the exponential form. Represent the following in the power form or in the exponential form. FORM. Okay, this is R. FORM. Okay, yeah. Please start writing. The first question is, write down the first question. A. The question is 8 into 8 into 8 into 8. Okay, please say the answer. How can we write this product in the exponential form? How can this be written in the exponential form? Yeah, what would be the base here? Yeah, the number which is being multiplied is known as the base. So, which is the base here? Yeah, 8 is the base. Okay, good. 8 is the base. 8 raised to, and how much? Yes, 8 is multiplied how many times here? Yeah, 4 times. 8 is multiplied 4 times. So, this is the power form or the exponential form, isn't it? 8 raised to 4. Any doubt? Okay, now let us move on to B. Minus 6 into minus 6 into minus 6. What is the answer? What is the answer? Yeah, here which is the base, the number which is being multiplied is called the base. Okay, isn't it? So, which is the base here? Yes, very good. Minus 6 is the base. Do we need to put this inside the bracket? Yes, of course. Negative integers have to be written inside the bracket, isn't it? Yesterday we discussed about that. And which is, what would be the exponent or power? What would be the exponent or power? Minus 6 is multiplied how many times? 1, 2, 3. So, what would, how many times? 3 times. Okay. So, what would be the exponent here? Yes, 3 is the exponent. Very good. This is the required exponential form or power form, isn't it? Okay. Now, please write down question number C. Question number C. The question is, write down C. Minus 4 into minus 4 into minus 4 into minus 4. Yes, what is the answer? What is the exponential form? Which is the base here? Yeah, base is the number which is being multiplied. What is it? Yeah, it is minus 4. And minus 4 is multiplied how many times? Yes, 1, 2, 3, 4. Isn't it? How many times? Yes, very good. 4 times. So, which is the power? Yeah, 4 is the power. So, this is the required exponential form, isn't it? Okay, now please write on question number D. D, the question is minus 13 into minus 13. What is the answer? I have chosen negative integers to make you thorough with this, because we need not put this, we need not write the exponent form of a negative integer without using bracket. The negative integer, every negative integer has to be put inside the bracket, okay, while denoting that in the power form, their product in the power form. Okay. So, which is the base here? Here which is the base? Which number is being multiplied here? Yes, minus 13. Very good. So, which is the base? Yes, minus 13 is the base. Minus 13. And what is the power here? How many times it is multiplied? Yes, 2 times. So, which is the power? Yeah, power or exponent is 2. Okay, good. So, now move on to next question. Question number E. Can we write the next question now? Yes, question number E. 24 into 24 into 24 into okay, sorry, this need not be written in the bracket. This is a positive integer 24, isn't it? Okay, 24 into 24 into 24 into 24 into 24. Yes, okay. Here, which is the number which is being multiplied is what? Yes, 24. Good. So, which is the base here? Yes, 24 is our base. Very good. And what about the exponent or power? What about the power or exponent? Yes, number of times this 24 is multiplied. It is multiplied how many times? 1, 2, 3, 4, 5, isn't it? So, which is the power of this 24 in this product? Yes, 24 raised to 5. 24 raised to 5 is the required answer. Got it? Any doubt? Okay, so shall we note down problem or homework from this session? Yeah, F is homework. If the question is homework. If the question is minus 7 into minus 7 into minus 7 or negative 7. Both are same. This is homework. G also homework. G and H are also homework. G, the question is 4 into 4 into 4 into 4 into 4. Homework, you have to write this in the power form. Okay. And H also homework. H, the question is minus 11 into, this is 11. Okay, minus 11 into minus 11. Minus 11 into minus 11. This is also homework. Okay. Have you written? Yes. Now, let us move on to the next second question. Second question is, read the following power forms. Question number 2, please write down. Read the following power forms. Question number 2. Read the following. Read the following power forms. Read the following power forms. Question number A. Base is 4 and power or exponent is 7. How it reads? How can this be read? How can we read this power form? Sorry, due to the problem of this pen I couldn't write. Okay, sorry. 4 is the base and 7 is the power. So, how could it be read? How can we read this? Yes, very good. 4 raised to 7, isn't it? 4 raised to 4 raised to what? Yes, 4 raised to 7, or in other words, how can this be read? Yes, 4 to the power 7, isn't it? Okay, good. Or 4 to the power 7. 4 raised to 7 or 4 to the power 7, isn't it? Okay, now please write down question number B. Write down question number B. B, the question is minus 12 is the base and power is 3. Minus 12 is the base and power is 3. And how it reads? How can we read? Please say how it reads. Yes, minus 12 raised to 3, isn't it? Yes, very good. Minus 12 raised to what? Yes, 3 is the power, isn't it? Or minus 2 raised to 3 or what? Minus 12, yes, to the power 3, isn't it? Very good. Or minus 12 to the power 3. Or minus 12 to the power 3. Minus 12 to the power 3, isn't it? Good. Now, write down question number C. See, the question is 31 is the base and 8 is the power. How it reads? Who can say? How can we read this? 31, yes, very good. 31 raised to 8, isn't it? Good. 31, this reads as 31 raised, this is 30 or 3, okay, sorry. 31 raised to what? 8. 31 raised to 8, or other way. What is the other way? Yeah, 31 to the power 8, isn't it? 31 to the power 8. 31 to the power 8, isn't it? Okay, now please note down question number D. Minus 15 is the base. Question number D. Minus 15 is the base and the power is 10. Minus 15 is the base and power is 10. How can this be read? How can we read this? Yes, minus 15 raised to, yes, 10. Very good. Minus 15 raised to, minus 15 raised to 10, or what other way? What is another way? Yeah, minus 15 to the power 10. Minus 15 to the power 10. Minus 15 to the power 10. Power 10. Very good. I think this much would be enough in this session. Please note down homeworks. Okay, is it enough? Okay, yes. E and F are homeworks. If the question is 13 is the base and 4 is the power, homework. If the question is minus 10 is the base and 5 is the power. 2 homeworks are there. Try to do today itself. Okay. Yes, very good. Now can we move on to the third question? Shall we move on to our third question? Yes. Third question is find the value of the following power forms. Question number 3, please write down. Find the value of the following power forms. Question number 3. Write down please. Find the value of the following power forms. Find the value of the following power forms. Okay, the first question is minus 1 to the power 6. How to find out the value of this? Minus 1 to the power 6 means what? Yes, what does it mean? Yes, it means minus 1 is multiplied how many times? Yes, minus 1 is multiplied, yes, 6 times. Minus 1 into minus 1 into minus 1 3 times into minus 1 4 times into minus 1 5 times into minus 1. We have multiplied minus 1 how many times here? Yes, we have multiplied minus 1. Yes, 6 times. 1 into 1 into 1 into 1. What is the answer? 1. And what about the sign of the answer? Yes, as per the rule of multiplying integers, if even number of minus are there, sign of the answer would be plus, and if odd number of minus are there, sign of the answer would be, yes, minus. So, how many minus are there in this question? 1, 2, 3, 4, 5, 6, or we can directly apply the rule for power forms has a rule. The even power of a negative integer is positive. We can directly apply that rule. Okay, that's better. Okay, very good. We can directly apply that rule. Even power of a negative integer is positive. Here is 6 even or odd? 6 is, yeah, 6 is an even number. So, even power of a negative integer. Of course, we know that minus 1 is a, yes, minus 1 is a negative integer. Minus 1 is a negative integer. So, even power of a negative integer is what? Yes, positive. Yes, as per the rule that has been learned yesterday, even power of a negative integer is what? Positive. So, here answer is what? Positive. Or plus 1 means what? Simply 1. Isn't it? Understood? Got it? Okay, now let's move on to second question. Please write down second question. Write down please. Question number B. The question is 8 raised to 3. Okay, what is the value of this? 8 raised to 3 means what? What does it mean? 8 raised to 3 means? Yes, 8 is, the integer 8 is multiplied how many times? Yes, 3 times. That is the meaning, isn't it? So, what is meant by 8 raised to 3? 8 is multiplied 3 times. That is 8 into 8 into 8, isn't it? Okay, 8 8s are 64. Very good. 64 into 8. Find this value in the working column. 64 into 8. 6 4s are, sorry, 6 8s are 32. 32 is 2 here. Balance 3 in the working column. 6 8s are, yeah, 48. 48 plus 3, 51. 512 is the answer. 512. 512 is the final answer. Isn't it? Okay. Shall we move on to the next question? Okay. Write down please. Question number C. Question number C. Minus 13 raised to 3. Question number C. Minus 13 raised to 3. Okay. What does it mean? Yes. Minus 13 is multiplied how many times? Yes. Minus 13 is multiplied 3 times. Isn't it? 3 is the power here. So, minus 13 is multiplied how many times? 3 times. Isn't it? So, what it would be? Minus 13 into, yes, minus 13 into minus 13. Okay. So, first let us find out the sign of the answer. How to find out the sign of the answer here? How to find out the sign of this answer? Yes, as per our rule, even power of a negative integer is positive and odd power of a negative integer is, yes, negative. Here, which is the power? Yeah, here the power is 3, isn't it? Is 3 an even number or odd number? Yeah, we all know that 3 is an odd number. So, odd power of a, of course, minus 30 is a negative integer. So, odd power of a negative integer is what? Yes, negative. So, negative is the sign of the answer, isn't it? Then, 13 into 13 into 13. Now, we found the sign as negative, isn't it? Now no need to write these 3 signs together. Why? Final sign of the answer is negative, that we have found by applying the result. Which is the result? Yeah, odd power of a negative integer is negative, isn't it? Now, let us find out the answer. 13 into 13. 3 3s are 9. 1 3s are 3. Put 1 0 down. 1 3s are 3. 1 1s are 1. 9 6 1. 169. 169 into 13. Isn't it? 169 into 13. So, let us find out 169 into 13 in the working column. 169 into 13. Isn't it? 6 9s are, yes, 27. Balance 2 in the working column. 6 3s are 18. 18 plus 2, 19, 20. 20 is 0 here. Again, balance 2 in the working column. 1 3s are 3. 3 plus 2, 5. Isn't it? Okay. Plus. Hope all of you know the multiplication very well. Do you know? Okay, then 1 9s are 9, 1 6 are 6, 1 1s are 1. Can we add now? Yes, 7 plus 0, 7, 0 plus 9, 9, 5 plus 6, 5 plus 5, 10 plus 1, 11, balance 1 above the previous number. 1 plus 1, 2. So, which is the final answer? Yes, 2197 is our final answer, isn't it? Got it? Yes, very good. Now, shall we move on to the next question? Question number D, write down please. 5 raised to 5. Question number 5, 5 raised to 5. Question number D, 5 raised to 5. What does it mean? 5 is multiplied how many times? Yes, 5 times. 5 is multiplied 5 times. 5 into 5 into 5 into 5 into 5, isn't it? Good. 5 5s are 25. 25 into 5 5s are 25 into 5 into 5, isn't it? You can multiply as per your convenience. Okay, this can be done as per your convenience. So, do as per your wish finally, but finally all of us will surely get the same answer, no doubt in that. So, let us multiply 25 into 25 first. 5 5s are, yes, 25, balance 2 in the working column. 2 5s are 10, 10 plus 2, 12, plus 2 5s are 10, 10, 0 here, balance 1 in the working column. 2 2s are 4, 4 plus 1, 5, yes, 5, 2, 6 is equal to 625 into 5, 625 into 5, that is equal to, again please find out the value of 625 into 5 in the working column. As I said earlier, this product can be found as per your convenience. If you want to find the product one by one, no problem at all. Okay, finally all of us will get the surely finally all the answers would be same, no doubt in that. Okay, 5 5s are 25, 5 here balance 2, yes, in the working column. 2 5s are Yes, 2 5s are 10, 10 plus 2, 12, 12 is 2 here, balance 1 again in the working column, isn't it? 6 5s are 30, 30 plus 1, 31. So, what is the final answer obtained? Yeah, 3125 is our final answer. Got it? Understood? Yes, good. Okay. Shall we move on to the third question? Shall we move on to the third, fourth? I think we have written D now. Now, let's move on to question number E. E, the question is, question number E, minus 11 raised to 3. Minus 11 raised to 3. How to find it? What does it mean? Minus 11 to the power 3 or minus 11 raised to 3 means what? Yes, minus 11 into minus 11 into minus 11 is equal to, what would be the sign of the final answer? Yes, as per the rule, what would be the sign? Yeah, odd power of a negative integer. Of course, we know that minus 11 is a negative integer and 3 is an odd number, isn't it? Odd power of a negative integer is, yeah, negative. So, we got the sign of the final answer as what? Sign of the final answer as what? Negative. So, this negative of 11 into 11 into 11. So, negative 11 into 11. First, find out 11 into 11 in the working column. 11 into 11. 1 ones are 1. 1 ones are 1. Plus, put a 0 down the first digit. 1 ones are 1. 1 ones are 1. So, 1, 2, 1 is equal to negative 121 into 11, isn't it? Okay, please try to find out this product. 121 into 11. 121 into 11, 121 into 11, 1 ones are 1, 1 twos are 2, 1 ones are 1, plus put a 0 down, 1 ones are 1, then yeah, 1 twos are 2, again 1 ones are 1. Now, we have to add, isn't it? 1, 2 plus 1, 3, 2 plus 1, 3, 1. 1331, 1331. This is the final answer. Got? Sorry, don't forget to put the minus sign. Minus is the sign of the final answer. We found that earlier. Don't forget to put the sign here. Okay, that's very important. If we forget to put the sign, the entire question would be wrong. So, please don't forget to put the sign. Okay. Yes, very good. Now, can we note down the homeworks from this session? F and G are homeworks. Can we note down? F and G are homeworks. Please note down F and G are homeworks. F 4 raised to 4 homework. G minus 3 raised to 2 minus 3 raised to 2 homework. H minus 6 raised to 3 minus 6 raised to 3. 3 homeworks are there. Please try to do today itself. Okay. Now, can we move on to the next question? I think now we have written up to question number 3. Now, let us move on to question number 4. Okay. Write down question number 4. Identify the base and power of the following exponential forms. Identify the base and the power. Identify the base and the power of the following exponential forms. Identify the base and the power of the following. Identify the base and power of the following exponential forms. Identify the base and the power of the following exponential forms. This is very, very easy, isn't it? Good. 2 raised to 6. Here, which is the base? No need to put the bracket here, isn't it? Okay. 2 raised to 6. Which is the base here? Yeah, very good. Base is equal to 2. Base is equal to 2. And power. Which is the power here? Base is 2 and which is the power? Yeah, no doubt. Power is 6. Power is equal to power is what? 6, isn't it? Okay. Any doubt? Yeah, very good. B, the question is minus 3 to the power 11. Minus 3 to the power 11. Okay, here which is the base? Let's denote the base by, okay, better to write base itself, sorry, base. Which is the base here? The number which is being multiplied is the base. So, which is the base here? Yeah, base is minus 3. And which is the power? Which is the power here? Yeah, power is very good, 11. 11 is the power. Got it? Okay, now let's move on to the third question. Question number C. Is it clear? Am I clear to you? Are you able to follow the concept? If you have any doubt, please feel free to ask or clear your doubts. Okay, so write down question number C. C, the question is 15 raised to minus 15 raised to, sorry, not 15, minus 15 raised to 7. Here, which is the base? Tell me, who can say which is the base here? Yeah, 15 is the base, isn't it? Yeah, base is equal to, base or base number is not 15, it is, yeah, very good, minus 15. Don't forget to put the minus sign. Okay, so base number is minus 15 and the power is what? Yeah, power is what? Yes, very good, power is 7, isn't it? Power is 7. Okay, yes, good. Now let's move on to question number D. Can we do the next question now? Shall we do the next question? Okay, now question number D. Minus 2 raised to 12. Minus 2 raised to 12. Okay, here which is the base number or base? Which is the base here? Yes, no doubt, minus 12 is the base, isn't it? Yes, base is equal to minus 12 and of course which is the power? Yes, power is very good, 12. 12 is the power. Power is equal to 12. Is it clear? Have you got? Okay, understood? I think this much would be enough. Okay, let's do one more. E 24 raised to 2. Okay, in this power form, which is the base? Which is the base of this power form? Yeah, 24 is the base, isn't it? Very good. Base is equal to what here? Yeah, it is 24. Okay, then which is the power? Power is equal to 2. Power is equal to 2. Good. Yes, now please note down the homeworks from this session. Shall we note down the homeworks? Shall we note down the homeworks from this session? Yes. Up to, I think, yeah, we have done up to F, isn't it? Next, G homework. The question is minus 6 raised to 8. Homework. G, H also homework. 4 raised to 6. Homework. I also homework. Minus 2 raised to 11. 3 homeworks are there in this session also, but very easy. You can do within seconds. No doubt in that, isn't it? Okay. Yes. Now let's move on to the next question. Yeah. Can we do the next question? Question number 5, isn't it? Yeah. Please write down question number 5. This question is regarding the sign of the exponent, sign of the power or negative sign of the power form, sign of the power form, isn't it? Okay, yesterday we have discussed. So write down question number 4, or 5, whatever it is, you please put the question number properly. Since the former questions have been rubbed, I couldn't identify properly. You please write it down properly. I think it is 5. Okay, write down. Find out or find the sign of the following power forms. Find the sign of the following. Find the sign of the following power forms. Find the sign of the following power forms. So what we have to do here? Yes, here we have to find out the sign. The question is regarding the sign of the power form. Here we have to find out the sign of the following power forms, isn't it? So write down question number A, minus 2 raised to 6. What is the sign of this power form? Who can say how to find out the sign of this power form, or which rule has to be applied for finding out the sign of this power form? Which rule has to be applied? Yeah, of course, we all know that negative 2 or minus 2 is a yes, minus 2 is a negative integer. So, and power is 6 here, and is 6 even or odd? Yeah, 6 is an even number, no doubt in that. So, yesterday we have learned 2 rules regarding the power of a negative integer. Do you remember? 2 rules, 2 very, very important rules. Yesterday we have learned 2 rules regarding the power of a negative integer. And what is that? Yes, even power of a negative integer is positive and odd power of a negative integer is negative, isn't it? Even power of a negative integer is positive and odd power of a negative integer is negative. So, here what about 6? Here is 6 even or odd? 6 is even. 6 is even. So, even power of a negative integer is what? Positive, isn't it? Sign is positive. Since the power 6 is even, so let's write like this. Since the power 6 is even, power 6 is even, the sign of this power form is, or the sign is what? Sign is positive, isn't it? Isn't it? Is it clear? Yeah, even power of a negative integer is positive. Since, so how can the answer be written? Since the power 6 is even, the sign is what? Sign is, yes, positive. What is the reason? Yeah, even power of a negative integer is positive, isn't it? Okay, now let's do second question. Question number B. Write down question number B. Minus 3 raised to 7. What about the answer here? Sign of the answer here. What about the sign of the answer here? Here the power is 7, isn't it? Here the power is 7. Is 7 even or odd? 7 is, yeah, 7 is an odd number, and the, of course the base is an base is a negative integer, okay, base is a negative integer here. So, which rule has to be applied? Yes, odd power of a negative integer is what? Yes, negative. Very good. Odd power of a negative integer is negative. Have you understood? Okay. Here, so how the answer has to be written? Yes, since the power 7 is what? Yeah, power 7 is odd. The sign is, yes, the sign is negative. The sign is negative. Have you got understood? Since the power 7 is odd, the sign is what? Negative. Very good. Next question. 4 raised to 6. Here, yeah, no need to think, no need for any confusion or any further thinking here. Why? Yes, this here base itself a positive integer. Since the base is positive, no need to think anything about that. Surely the sign would be positive. So, here we can here directly we can write the answer as positive, isn't it? Here surely we can write the answer as positive. Why? Yeah, base is a positive integer. Base is a positive integer, isn't it? Okay. Now, write down question number D. Please write down question number D. D, the question is 16 raised to 2. Here also, what would be the answer? Do we need to think anything? Do we need to think about this? Is there any scope for further thinking? Not at all. Directly we can write the answer here. Why? Yes, here also base is a positive integer. Base is a positive integer. So, without any doubt, what would be the sign of the answer? Yes, sign of the answer would be positive, isn't it? Okay, very good. Now, let's move on to question number E. Up to E we can do, and F, G, H are homeworks. Okay, is it clear? Have you understood? Are you able to follow this? Is it clear? Okay, E, the question is minus 4 raised to 11. Okay, here what about the sign of the answer? Base is a negative integer here, and what about the power? Power is 11. Is 11 even or odd? Yeah, we all know that 11 is a odd number. So, what would be the sign? Yeah, odd power of a negative integer is negative, isn't it? Very good. So, how can we write the answer? Since, yes, the power 11 is odd, isn't it? Since the power 11 is odd, the sign is, what would be the sign? Yes, very good, sign is negative, isn't it? The sign is negative. Good. Is it clear? Okay, F, G, H are homeworks. F homework 4 raised to 8. 4 raised to 8. Okay, G, the question is minus 6 raised to 4. Homework. H also homework. H, the question is minus 11 raised to 3. 3 homeworks are there from this session. Here also it is very easy. We should know the results which have been learned in our last class regarding the power of a negative integer. What is it? Yeah, odd power of a negative integer is negative, and even power of a negative integer is what? Positive. Got it? Is it clear? Okay, hope you understood the concept very well. Thank you. Have a nice day. Okay. Laws of exponents. Exponents can be written as powers, indices, etc. Okay. What is the plural of index? Plural form of index is indices. Laws of exponents or laws of indices. Laws of exponents or laws of indices. Indices means plural of index, plural form of index. Okay, have written. So let's write the first law. Let's start. Okay, before that we have to write some common notes, then we shall write Roman number 1, 2, etc. Let A be an integer. Okay, let A be, write down please, let A within single inverted comma, A be an integer. Let A be an integer. So what is A? Suppose A is an integer. That what does it mean? Let A be an integer means suppose A is an integer. Within bracket we can mention integers. Which are integers? Yes, there are negative integers, there are positive integers, and of course there is 0. Okay, integers means negative integers, positive integers, and 0. So we have learned in the lesson of integers. Minus 3, better to write in the next line. Okay, integers are within bracket. Please write down the integers. Which are the integers? Yeah, integers has no beginning and no end. We have discussed it in the integers lesson well. So minus 3, then minus 2, then minus 1. After that, next integer is what? Yeah, 0. Then we have 1, 2, 3, etc. It goes on like this. These are integers. Negative integers, 0 and positive integers. It has no beginning. Integers have no beginning and no end, isn't it? Yeah, these are integers. So let A be an integer means A can be any one of these integers. Understood? Let A be an integer means A can be any one of these numbers. Okay, an integer, and M and N are within single inverted comma M. M and N are whole numbers. M and N are whole numbers. Okay, do you remember which are whole numbers? Whole numbers are numbers from numbers 0, 1, 2, 3, etc. are known as whole numbers. Numbers 0, 1, 2, 3, etc. Whole numbers. W is equal to 0, 1, 2, 3, etc. are known as what? Whole numbers. Numbers 0, 1, 2, 3, etc. are known as whole numbers. We have discussed all these things in detail while learning the lesson. Integers, isn't it? Okay, whole numbers are numbers 0, 1, 2, 3, etc. Integers are minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. And here we have, is there any number before this minus 3? Yeah, of course. What is it? Yeah, minus 4. After that we have minus 5, etc. Isn't it? So let A, what is A? A is an integer, and M and N are, yes, M and N are whole numbers. This is the first step of this laws of exponents. Have you written up to this? So what is A? Yeah, A can be any one of these integers. And what are m and n? Yeah, m and n are two whole numbers, isn't it? Okay, then the first law of exponent is a raised to 0 is equal to 1. What is the first law of exponent? A raised to 0 is equal to 1. So, let A be any integer. Now, it does not matter. A to the power 0. Any number to the power 0 is what? 1. This is a very important rule. Any number to the power 0 is equal to 1. Okay, after completing A raised to 0 is equal to 1. After writing up to this, you please stop writing and listen here directly, properly listen here. Listen well. Okay, after completing this, please stop writing and listen carefully. Okay, let A be any integer. So, can A be 1? Yes, A can be 1. Can A be 2? Yes, can A be a minus 2? A can be minus 2, no problem. Why? A can be any one of the integers. A can be any one of the integers. So, can we take A as minus 15? Yes, we can take, no problem. A is an integer. Can we take A as 412? Can we take A as 412? Yes, of course, we can take A as 412. Why? 412 is an integer. Yes, very good. Can we take A as 2.5? Can we choose A as 2.5? Who can say? Can we choose A as 2.5? Not at all. Why? Decimal numbers are not. Is 2.5 a decimal number? Yes, 2.5 is a decimal number. So, decimal numbers are not integers. So, we can't choose A as 2.4, 2.5, 2.4, 15.2, anything like that. Okay, A cannot be a decimal number. A is what? A is an integer. Okay. So, for any integer A raised to 0 is equal to 1. That means, what is the value of 2 raised to 0? What is the value of 2 raised to 0? Yes, of course, 2 is an integer. So, A raised to 0, instead of A raised to 0, can we write 2 raised to 0? Yes, we can write. So, what is its value? Yeah, 2 raised to 0 is also is equal to 1. Any integer raised to 0, any integer to the power 0 is equal to 1. Understood? Any integer to the power 0 or any integer raised to 0 is equal to 1. So, what is the value of 4 raised to 4 raised to 0? What is the value of 4 raised to 0? What is it? Yeah, 1. Any integer raised to 0 is 1. So, 4 raised to 0 also would be what? Yes, 1 itself. What is the value of minus 15 raised to 0? What is it? Yes, 1. Very good. No doubt in that. Okay, let A be any integer, no problem. That integer to the power 0 is equal to what? 1. Integer raised to 0 or any integer to the power 0 is equal to 1. Understood? So, this is a very important law of exponent. So, can we continue writing? Yes, below this, please write down. This is a rule. Don't ask why, ma'am, it is so. There is no question in learning the rules. It is a rule, so you have to by heart it. Any integer raised to 0 is equal to what? 1. Okay. Down, please write. Any integer to the power 0, any integer to the power 0 is equal to 1. Or in other words, how can it be written? How can we write this in other words? Or any integer, please say, what is another way of writing this? Yes, any integer raised to 0 is equal to 1, isn't it? Very good. Any integer raised to 0 is equal to 1, isn't it? Very important result. Have you understood? Is it clear? So, let us write down some examples. Example 2 raised to 0, 2 to the power 0, 2 raised to 0 is equal to what? What is the value of 2 raised to 0? Example A, 2 raised to 0, 1, isn't it? Let A be any integer, no problem. It's that integer to the power 0 or that integer raised to 0 is equal to what? Is equal to 1. Understood? Is it clear? Okay. Example B, minus 5 raised to 0 is equal to, what is the answer? Is minus 5 an integer? Yes, minus 5 is an integer. So, minus 5 raised to 0 is equal to 1, isn't it? C, minus 21 to the power 0, what is it? Yeah, that's so good, is equal to 1. Okay, D, example D, 9 raised to 0 is equal to dash. What is the answer? Is 9 an integer? Yeah, 9 is an integer. So, 9 raised to 0 is equal to 1. Okay, next one, example E. Please write down example E. Minus 6 to the power 0. What is the answer? Yeah, minus 6 is an integer. So, the answer is 1 here. Understood? So, what is the first law of exponent? Let a be any integer, then a to the power 0 is equal to 1. That is the first law. Understood? Okay, now please write down the second law. After that, we shall explain that. We shall explain the second law. Second law, Roman number 2. A raised to 1 is equal to a. This is the second law. A raised to 1 is equal to what? A. This is the second law. So, let a be any integer, a can be any of the, a can be a number from the set of integers. A can be any integer, then a raised to 1 or a to the power 1 is equal to what? A, isn't it? Understood? This also has to be by hearted, no other way. This is also a rule, so you have to by heart it, no other way. So, after writing this, stop writing and listen carefully. So, what is the value of 2 raised to 1? A raised to 1 is 1. So, 2 is 2 an integer? Yes, 2 is an integer. So, what is the value of 2 to the power 1 or 2 raised to 1? Yes, it is 2 itself. Okay. So, what is the value of minus 4 to the power 1? Minus 4 raised to 1, what is the value? Yes, very good. Since minus 4 is an integer, any integer raised to 1 is equal to the integer itself. So, what is the value? Yeah, minus 4, isn't it? Okay, then let me ask one question. 16 raised to 1, what is the answer? Is 16 an integer? Yes, 16 is an integer. So, what would be the answer here? 16 raised to 1? Yes, very good, 16. Like that, 255 raised to 1, what is it? Yes, 255 itself, good. Are you able to follow this? So, what is our second important rule or law of exponents? Yeah, any integer to the power 1 or any integer raised to 1 is equal to the integer itself, isn't it? Okay, that is the second rule. So, please start writing again. That is any integer to the power 1, any integer to the power 1, any integer to the power 1 is equal to the integer itself, that integer itself, that integer itself, that integer itself. Any integer to the power 1 is equal to that integer itself. These laws of exponents are very, very important. Any integer to the power 1 is equal to that integer itself, or in other words we can write how can we write in other words? Yes, any integer raised to 1 is equal to yes, the integer itself. Any integer raised to 1, any integer raised to 1 is equal to yes, the integer itself, the integer itself. This is the second law of exponent. Any integer to the power 1 is equal to that integer itself, or any integer raised to 1 is equal to the integer itself. Got it? Understood? This is the second law of exponents. Can you say some examples? Can you say? Please try to say some examples, or please try to write some examples yourself. A, please say one example. Yeah, 2 to the power 1 or 2 raised to 1 is equal to what? Yeah, the integer itself, 2, isn't it? B minus 5 to the power 1 or minus 5 raised to 1. What is the answer? Yes, minus 5 itself. Yes, very good. C write down please. C minus 4 to the power 1. What is the answer? Is 4 an integer? Yes, 4 is an integer. So, here what is the answer? Yeah, minus 4. Very good. D 50 to the power 1 or 50 raised to 1. What is the answer? Yeah, 50 is the answer. Isn't it? Any doubt? Okay. E minus 24 to the power 1. What is it? What is the answer? Minus 24 to the power 1. Yes, the answer is minus 24 itself. Okay. First, please try to write down the notes. After that, we shall do the problems. Okay. E minus 24 to the power 1 is equal to what? Minus 24. This is the second law of exponents. Okay. We have learned two laws now. The first law is any integer to the power 0 is equal to, yes, 1. Any integer to the power 0 is equal to 1. That is the first law. And the second law is any integer to the power 1 is equal to that integer itself. Any integer to the power 1 is equal to that integer itself. Isn't it? Okay. Okay. After completing up to this, please stop writing and listen carefully. Stop writing please and listen carefully. Let me ask one question. What is 2 raised to 2? What is 2 raised to 2 into 2 raised to 3? How can we find this? Can we find this? Yes, of course we can find. Why? We know the value of 2 raised to 2. What is 2 raised to 2? What is meant by 2 raised to 2? Multiply 2 times. Isn't it? 2 into 2. 2 raised to 2. Instead of 2 raised to 2, can we write 2 into 2? Yes, of course. Why? 2 raised to 2 means? Yeah, 2 into 2. Into, what is 2 raised to 3? Instead of 2 to the power 3 or 2 raised to 3, what can we write? Yeah, 2 into 2 into 2. Instead of writing 2 raised to 3 or 2 into 2 into 2 to the power 3, we can write, can we write 2 into 2 into 2? Yes, 2 raised to 3 means 2 into 2 into 2. And of course, what is, so now all together we have here instead of 2 raised to 2, we have written 2 into 2. Isn't it? Instead of this 2 raised to 3, we have written 2 into 2 into 2. So, all together, how many 2's are there together? 1, 2, 3, 4, 5. 5 2's are there. 2 into 2 into 2 into 2 into 2. 2 is multiplied how many times? Multiplied 5 times. So, product of 2 multiplied by itself 5 times. What is it? 2 is multiplied 5 times. What is the exponential form of 2 multiply? 2 is multiplied 5 times. 2 is multiplied 5 times. What is the exponential form? Yes, 2 to the power 5. Very good. 2 to the power 5 or 2 raised to 5. Understood? 2 to the power 5 or 2 raised to 5. Isn't it? 2 is multiplied 5 times means 2 to the power 5. Okay. So, yeah, actually we got 2 to the power 2 into 2 to the power 3 is equal to 2 to the power 5. 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 5. So, can you find the relationship between these two? We got the answer as we found that 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 5. On multiplying two powers, their exponents get, but is there any relation between 2, 3 and 5? Is there any relation between, any connection between 2, 3 and 5? Who can say? Can we connect 2 and 3 with 5? Can we connect 2 and 3 with 5? Yes, of course. We know that 2 plus 3 is equal to 5. We know that 2 plus 3 is equal to 5. That is the relationship between 2, 3 and 5. So, on multiplying two power forms, their powers get added. Isn't it? On multiplying two power forms, 2 raised to 2 is a power form and 2 raised to 3 is a power form, and on multiplying these two power forms, in the answer what happens? Their powers, here power is 2 and here power is 3. Their powers get added. That means we can say that 2 raised to 2 into 2 raised to 3 is equal to, what is 5? 2 raised to 2 plus 3. 2 raised to 2 into 2 raised to 3 is equal to what? 2 raised to 2 plus 3. Understood? 2 raised to 2 into 2 raised to 3. From this we can conclude that, from all these we can conclude that 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 5. But instead of this 2 raised to 5, we can write what is 5? 5 is 2 plus 3. So we can write 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 2 plus 3. 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 2 plus 3. Got it? Understood? So generally what can we write? How can we say this rule generally? This is the case of 2 raised to 2 and 2 raised to 3, but this is applicable for all integers and all whole numbers as powers. Okay, so generally can we write a raised to m? Instead of 2 we can write a. Can we write a where a is an integer? Where a is an integer? Instead of this 2, can we write a, an integer? In the beginning itself we have written that a is let a be an integer. So instead of can we replace this 2 by a? Yes, of course we can replace. Why a is an integer here. So a raised to, instead of 2 can we write m where m is a whole number? Yes, we can write m is a whole number. A raised to m into a raised to n, instead of 3 we can write n, another whole number, is equal to, what would be the answer? A raised to m into n, a raised to n is equal to 2 raised to, instead of 2 we can write a, 2 raised to what? A raised to, instead of 2 plus 3 what can be written? A raised to, yes, m plus n. A raised to m plus n. This is the very important rule of product rule of exponents. This is a rule regarding the product of two exponents, isn't it? This is a rule regarding the product of two exponents. And what is that rule? A raised to m into a raised to n is equal to a raised to m plus n. A raised to n. You have to by heart this rule, no other way. What is the product law of exponents? What is the product law of exponents? Yes, let a be an integer and m and n are whole numbers, then a raised to m into a raised to n is equal to a raised to m plus n. This is known as the product law of exponents. Or in words, how can we state this? How can we state this product law of exponents in words? Yes, this can be stated as, on multiplying the different powers of an integer, their powers get added. On multiplying different powers of an integer, their powers get added. That is 2 raised to 3 into 2 raised to 4. What would be the answer? This is the third power of an integer. This is the fourth power of an integer 2. And in the answer what happens? Their powers get their powers get added. So 2 plus 3, sorry, not 2 plus 3, 3 and 4 are there, isn't it? 2 raised to 3 plus 4, that's equal to 2 raised to 7. Got it? Understood? On multiplying the different powers of an integer, their powers get added. That is the, in words we can state the product law of exponents like this. Have you got? Understood? So what is the product law of exponents? A raised to m into a raised to n is equal to a raised to m plus n. A raised to m into a raised to n is equal to a raised to m plus n. That is the product law of exponents. This is very important. Product law of exponents. Rule 3 or law 3. Product law of exponents. Product law of exponents or product law of powers. Product law of exponents. Please write down product law of exponents. Product law of exponents. Okay, please write down product law of exponents. Let yeah, already we have written a, b, an integer, and all those things have been written earlier, isn't it? Okay, a raised to m into a raised to n is equal to a raised to m plus n. A raised to m into a raised to n is equal to a raised to m plus n. This is very, very important. And how can this be stated in words? In words, on multiplying two powers of an integer, on multiplying two powers or different powers of an integer, on multiplying 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 different powers of an integer, their powers get added. On multiplying different powers of an integer, their powers get added. On multiplying different powers of an integer, their powers get added. On multiplying different powers of an integer, what is the rule? Their powers get added. On multiplying different powers of an integer, what happens? Their powers get added. A raised to m into a raised to n is equal to a raised to m plus n. This is a very, very important law of exponents, and it is known as product law of exponents. A raised to m into a raised to n is equal to a raised to m plus n. Understood? Have we got? So, we have learned the first rule. What is law? Which is that a raised to 0 is equal to 1. And what is the second law? A raised to 1 is equal to a. And here comes our third law, product law of exponents. What is that? Yes, a raised to m into a raised to n is equal to a raised to m plus n. Got it? Okay, so write down example A. 2 raised to 3 into 2 raised to 4. Write down please. Instead of this 2 raised to 3, we can write what? 2 raised to 3 means multiplying 2 how many times? 2, yeah, multiplying 2 3 times. 2 is multiplied how many times? 3 times. So, instead of 2 raised to 3, we can write what? Yeah, 2 into 2 into 2, isn't it? Yes, into this into, and instead of 2 raised to 4, what can be written? Instead of 2 raised to 4, what can be written? Yeah, 2 is multiplied how many times? Yeah, in 2 raised to 4, 2 is multiplied how many times? Yeah, 4 times. So, 2 into 2 into 2 into 2, isn't it? Yes, good. So, instead of 2 raised to 3, we have written 2 into 2 into 2, isn't it? And instead of 2 raised to 4, we have written 2 into 2 into 2 into 2. So, all together, how many 2's are there? These two together, all together, how many 2's are there? All together, 2 is multiplied how many times? Yeah, 1, 2, 3, 4, 5, 6, 7. All together, 2 is multiplied how many times? 2 is multiplied 7 times. 2 is multiplied 7 times means what? 2 raised to 7. Isn't it? Okay, good. This is equal to, we know that what is 2 raised to 7? Sorry, what is 7? 7 is equal to 3 plus 4, isn't it? Okay, that's equal to, here we have written 2 raised to 7. That's equal to 2 raised to, instead of 7, what can be written? We know that 7 is equal to 3 plus 4. 3 plus 4, not 2 plus 3. 7 is equal to 3 plus 4. We know that 7 is equal to 3 plus 4. So, instead of this 7, what can we write? Yeah, we can write 3 plus 4. We can write 3 plus 4. Got it? Understood? So, 2 raised to 3 into 2 raised to 4 is equal to 2 raised to 3 plus 4. Have we got? Is it clear? Yes. Now, let's move on to the next example. Let's move on to the next example. Example B. Now let's move on to the next example. Example B. Example B. 4 raised to 2 into 4 raised to 5. How can we do this? How can we do this? What is 4 raised to 2? What is 4 raised to 2? Yeah, 4 raised to 2 means 4 is multiplied how many times? Yes, 2 times. So 4 raised to, instead of 4 raised to 2, we can write 4 into 4, isn't it? Now into, this into 4 raised to 5. What is meant by 4 raised to 5? What is 4 raised to 5? Yes, 4 is multiplied how many times? Yes, 5 times. So 5 into, sorry, 4 is multiplied 5 times. Sorry, okay. 4 is multiplied how many times? 5 times. 4 into 4 into 4 into 4 into 4. 4 is multiplied 5 times. 4 into 4 into 4 into 4 into 4. So instead of this 4 raised to 5, what can we write? Well, yeah, we can write 4 into 4 into 4 into 4 into 4, isn't it? So all together, how many 4s are there? How many 4s are multiplied together? How many 4s are multiplied each other? All together, how many 4s are there in this product? 1, 2, 3, 4, 5, 6, 7. Isn't it? How many 4s are there in this product? Yeah, 7 4s are there. 4 is multiplied how many times here? 4 is multiplied 7 times. What does it mean? 4 is multiplied 7 times means what in the power form? 4 is multiplied 7 times means 4 raised to 7. 4 raised to 7 is equal to, but we know that 7 is equal to, yeah, 2 plus 5. We know that 2 plus 5 is equal to 7, or 7 is equal to 2 plus 5. So we know that 7 is equal to 2 plus 5. So instead of this, we can write 4 raised to what? Yeah, this 7 can be replaced by, yeah, 2 plus 5. Why? Yeah, we know that 7 is equal to sum of 2 and 5. 2 plus 5. So 4 raised to 2 into 4 raised to 5 is equal to 4 raised to 2 plus 5. 4 raised to 2 into 4 raised to 5 is equal to 4 raised to 2 plus 5. This is the second law of exponents. Sorry, third law of exponent, and it's of course a very important law. More examples can be done while doing the exercise problems. Don't worry about that. So I think we shall wind up this class now. We shall wind up this class. Tomorrow we shall do one more, we shall discuss one more law, and after that we shall do the problems from this session. Okay, hope you understood the concept very well. Thank you. Have a nice day.